All right, we're rolling. Okay, you guys, this is my husband Shane.
Hello.
He does construction, among many other things. Anyway, today I gave my students a question about checking to see if a wall is square. But first I want to ask you, what does it mean to be square in construction?
Well, we use the term square to mean several different things, and in terms of geometry, we may not be very accurate in using the term square, but however, I'm going to explain what it means in construction. Square means, like, if you were making a wall square, that the two opposing sides would be equal length, and the top and bottom would be equal length, and then all of the inside angles would be 90 degrees. So if your wall was leaning a little bit to one side, then those angles would not be 90 degrees. But if the wall was standing perfectly straight up and down, those inside angles would have to be 90 degrees. So we would say that wall is square.
Okay, so, and because like the way we use the word square, it would mean all the sides are the same length. You're saying the way they use square in construction is like it's a rectangle, right?
Right.
Okay. So you build a lot of walls. So how do you check to see that your wall is square and not like slanted to one side?
Well, the first thing that would be helpful to explain is that often we build the walls laying flat on the ground. So it wouldn't work for us to have the wall standing up and make sure that the sides are straight up and down, or plumb is the word we use for that. So when a wall is laying flat on the ground, the easiest way is to do what we call pulling diagonals. And so basically, layman's terms would be measuring kitty corner from one corner to the other, or measuring the diagonal. And if that rectangle or square is perfectly square, the diagonals will be exactly the same. So what we would do is put a tape measure across going both directions, and if the numbers were different, then we would make slight adjustments until they were the same, and then we would lock it in right there.
Awesome. Okay. So I just want to go over a couple other ideas that my students had about how you would check to see if they're square. And we have some tools here. So the first thing, yeah, I think we have you called it a framing square.
Correct.
Okay. So could you put that framing square in the four corners of your wall, and would that mean that it's also rectangular?
Well, in a perfect world, if all of your lengths were equal to their opposite side, so the bottom length and the top length were the same, and the side lengths were both equal to each other, in a perfect world, you could put this in one of the corners, and that would work to make a square wall. But in reality, that would be not very accurate. What we find is that simply putting this in one corner will not make the rest of the wall perfect. But pulling diagonals is a much larger scale measurement that gives us much more accurate walls.
Okay, cool. Then the other one, I think a couple of my students suggested using a level. Would you ever consider using a level to check if a wall is square?
Well, yes, that's an excellent way to do it. If you run into a situation where you build a wall, the framing of the wall, and then the plywood goes on the outside of the wall, before you put that on, you would make the walls what we call plumb, and that's the same as putting a level on the side. However, most carpenters would not just use a level because it also would not be as accurate.
In terms of scale, it would like you'd have to do
Right,
the whole
like,
thing.
you know, this is a 2 foot level, so it's really only telling me that 2 feet of that 8 foot wall is plumb. So, and plus these are notorious for not being very accurate.
Oh, okay.
So we might use a plumb bob, or actually nowadays we actually use a laser level, which is, or a laser plumb, which is fairly accurate.
Okay. So one more kind of question. So we've talked about this thing called an isosceles trapezoid. Are you familiar with what that
Sure.
is? Okay. So also when you take the diagonals of an isosceles trapezoid, they're also congruent. Or, I mean, in our cases, sorry, they're the same length. I know that you don't use the term congruent in construction. So is it common or possible that you could build a wall that's actually a trapezoid?
Using, when you're pulling diagonals,
Yeah, like you'd
Yes.
pull it up.
you could build a perfect isosceles trapezoid. Is that what you called it?
Yep.
You could build one of those perfect using pulling diagonals. However, if you were typically in construction, we want everything to be perfect squares or rectangles, and so if you ended up with a isosceles trapezoid, it would be because you cut one of your pieces of wood the wrong length. So your base would be longer than, along the bottom, would be longer than the piece along the top.
Yeah, and I guess
Or
what are the boards that are like, sorry, like they're
the studs.
the studs. So the studs would have to be really slanted. That might be more obvious.
Yeah, and then if this, you would run into problems where that wall runs into another wall, because then your corners wouldn't match, and then the wall. So if you had this wall and it was leaning like this, and then you brought it to this wall would then have to be leaning.
Right. So in the terms of counter example, it's definitely possible, but it doesn't happen that often. Is what you're saying.
It does happen, and immediately you recognize that you cut one of your we call them plates. You would call them your I guess base, or
Yeah.
in geometry. But immediately you would recognize that you cut one of your plates wrong, and you would have to then replace that one.
Okay. All right, we're out of time here, but thank you so much. And you look really good on camera.